All right, thanks for coming. As Phil said, my name is Matt. Um, just to get started, I'm talking about mining for vulnerability IDs, and it's sort of a case study on a couple of projects I've worked on. So basically, just to introduce myself and to set some context about where this talk comes from, I've been doing security for a while, both offensive and defensive stuff, a lot around homebrew solutions and so on. I help organize this conference and Breakpoint as well.
Hello! You need to use the mic.
Oh, thanks.
It's not loud enough back here.
Okay. So yeah, basically help organize this conference and Breakpoint, and now I work for myself as Vuln Security. I mostly do in-depth security assessments and so on. And when I get spare time, it's working on stuff like what I'll be talking about today, mostly data-related stuff. Basically, there's three main motivators for this work. The first one, I'll just sort of glance over them quickly, but public vulnerability information, I'll explain why. Keeping up with information security news each day. And the third one is auditing open source code for bugs. To elaborate in some detail, basically I was doing a project a few years back for a company where we're taking a bunch of threat and vulnerability intelligence feeds and making a console for some analysts. And when there's information about bugs which were public but it's not in the private feeds, they're all saying this information sucks, like there's no good technical information. And it's a pretty hard problem to solve because it's all, this is all upstream and this information flows through a lot of security products and is seen by a lot of technology and people as well. Lots of time delays, missing information, references and so on. Lots of unknown vectors and unclassified vulnerability. This stuff is like these NIST initiatives and so on. A lot of stuff is built for like security technology integration, and there's people who are looking at this information as well. This is pretty straightforward. Basically, it's really hard to keep up with the news, Twitter, and that. Even I'm using Twitter, I think it sucks. So basically, how to use this information to make something which could be better and to be more time efficient each day. This final point, I know these are really three completely different points, but this final one is about auditing code. I spend a lot of time doing this, and my experience is top-down methodologies for entry points and working out where you can start from. Several years ago, that was easy. Nowadays, you need to know like a much more intricate understanding, and the bugs are usually really application-specific. So yeah. So social media mining is the first part. I'll be talking about a tool called Talkback. There's the vulnerability-related information and also the trending item information. And then I'll be finishing up doing a preview on some stuff I've been doing recently around code analytics, and it's a tool called Tabasco or Hot Source. So social media. The medium is Twitter, or primarily Twitter. Everyone should know it. There's heaps of data, which is good, but there's heaps of noise, and that adds some interesting challenges. So my concept is pretty simple. Basically, use Twitter API. I want to mine for vulnerability references, and the reason for this is a few. Basically, these are pretty universal IDs. So when people refer to a vulnerability and they reference it, they usually do it explicitly. So if they're doing an analysis, then they go, oh, I'm talking about this particular vulnerability. It also means that it's Unicode text. So this mining process works over many languages as well. If you do mining on foreign mediums, you sometimes have to consider a lot of annoying stuff if you're doing it on many languages. So that sort of skips that pretty easily. And it's specific, so it's pretty short character sequences that when you mine Twitter for all the crap that flows through it every second, it's a really small data set to work with. So just a really quick prototype. Iterate through heaps of vulnerability prefixes, so you capture the data in bulk. You validate that it's not just some weird acronym. Expand the metadata and build up a data model. And fetch more information. We want to get like coordinates for users and so on if possible. And then we want to visualize it. I chose something called simile widgets, which is from some guys at MIT. And it means you can go from data to a UI really, really, really fast. So this is like mining. You can see lots of Unicode text. Lots of metadata to work with, like language codes and so on, which comes back, which is interesting. This is about getting coordinates using Google Maps API. And this is just like simile widgets is you define a data model and you define a data source. Everything falls together and they give you a bunch of user interface panels to say, I want a map or a time plot or a timeline. And it's like hardly any code and you get something that looks pretty good. So I wanted to get through that pretty quickly. Basically, with vulnerability references, this is probably one of the main focus points of the tool. But you have that mining process, that basic prototype. One of the first things I had to consider was dealing with the way information comes back from Twitter when you mine for it. So if you get, let's say, 5 people talking about vulnerabilities in 1 minute, for example, basically there's things such as hashtags and URL shorteners which change the text. It's not unique. So they all might be talking about the same thing or like adding hashtags or just doing whatever on what they do on Twitter. But you could look up all that information and find how many retweets it has and factors that into some logic. But I found it's, I'll give an example. You might have some guy saying, oh, that sounds awesome, and someone else saying, oh, here's how you trigger it with Nmap. And then with another vulnerability, there's an analysis. But basically, there's only 4 unique messages here, and that's really common where you have dozens of people saying pretty much the same thing at one point. So first thing I had to do was factor this in. So the logic's pretty straightforward where a new vulnerability reference will come in, and you want to fetch any historical messages that match that same sort of pattern. And I use sort of like longest common sequence for that, where a quick way of doing it in Python is using difflib sequence matcher and building a ratio between the new string coming in, and you iterate through in order of time to work out what was the original message, which had that sort of construct, and then just map them. So it works through noise really quickly doing it this way. And then you end up with a pretty basic data model, like there's other entities and stuff, but basically we have items which have been mined, we map them to vulnerabilities, to what vulnerabilities have been referenced. Items can point to a parent and have weightings and so on, and then the people who are talking about it are just referred to as origins. The basic features, in a nutshell, you have all this mined data, you can browse and search and do all that sort of stuff. But you can look up a specific vulnerability reference, which is what I'll be doing today and looking at some of the results of this system. You can browse the people who talk about vulnerabilities, which is actually pretty interesting as well. And you can view like statistics and trends and stuff, which I've put together, and web services and feeds. So to sort of like explain this screenshot, on the top you have the navigation. On the left you have what Simile calls facets, which is filters, searching. It's nice because it makes a one-off request to the data source, and then everything happens on the client, so it's nice and fast. But on the right, you can see a timeline, which is the default view in this UI. And you can see there's like two bars. Top bar is by hour, and the bottom one is by day. So you can see there's a pretty steady stream of people talking about bugs in one way or the other. You can click on some item and get like what someone said. You can click on his name and get information about him, or you can click on the timestamp and get the original message. There's a Google Maps, Google language translate thing there as well on the right, and you can translate the text, and that will just all happen in the browser as well. If I switch to Maps view, this is lots of screenshots. So this is like a 30 meg PDF. Basically, I did a keyword search for proof of concept. This is an example. And then I changed to maps view, so you get this map of people talking about bugs, and they're color-coded by how heavily they were weighted. So I click on this guy in Thailand, and he's like saying, here's my like proof of concept for this particular PHP bug. Another view is searching for Chrome, and on the bottom left, you can see I filtered by the weights. So for some reason, I called them by like boxing weights, but I added obese because there was like some items that were coming really heavier after that. And so you can filter to say what was popular in some way. I flip it to grid view, sort by the child items, and then I can see what was most popular talking about Chrome for a certain weight. And then I can click on his name, and then it gives me a pop-up about what other stuff the system has picked up, what he's been talking about. And I can click on Boston, Massachusetts, and see who's from there as well. This is an example of when you look up a vulnerability and I embed something from CV details. This guy kindly set it up for me where it just basically shows the core information from NVD. But then I have my statistics under that. So you can see like dynamic timelines for the vulnerability as well. And I have a bunch of examples to go through. This is NVD. This is the National Vulnerability Database. Used really heavily. A lot of products integrate with this. And you can see that it has basic description. If you don't know what CVSS metrics are, you're not really missing out on much. But basically, yeah, I'll explain why. There's reasons for that. This is probably the key point. Like, these are references. So a lot of security technology integrate with this for patching and like vulnerability management. But there's nothing about analysis. There's nothing about like post-mortems and so on. But in TalkBack for the same vulnerability, we have analysis from Microsoft, from WebSense, stuff about targeted attacks in Korea, another analysis by, that was a really good one. And then we have a Metasploit module. So you have all this other cross-referenced information that's come through. If I change the view, when you look up a vulnerability to timeline, it sorts it by day and by week rather than hour, and it's different amount of data. And you can see someone saying, oh, this is the Metasploit module for this particular bug. And then you see in the timeline at the top, you can see that equivalent in the peak that happens. So these, sort of interesting, it's a 1-year gap. So the reason why these vulnerability feeds, it's hard to maintain the information, is because they're always changing, and there's like thousands and thousands of bugs for these guys to maintain. The other interesting thing is you can use language code and so on for what people are talking about. English is easily like the predominant language, but you can see an increase in Korea here, and that's because there was targeted attacks for this particular vulnerability. And I've got some examples. Users who talk about vulnerabilities, there's over 20,000 from my mining process so far. I sort of zoomed in on just a portion of the world, just to sort of give an idea about. Yeah. And data feeds. They're pretty basic, but I'll show one example of how someone used this data. So interesting trends and findings is pretty much like, I committed to give this talk, and it forced me to look at the data and sort of understand what was interesting. And some of it's really interesting, so this is that part. This is a copy and paste from the statistics page. And what I've done is, I've got one part which is 2011, the other part which is 2012. I've just added, I hope you can see it, but I just added labels for the vulnerabilities. So in small text, you can see the vulnerability ID. The top one here is, so there's 20 bugs distributed here. And you can see they're ordered by time for the year. I started mining in end of Q1 last year. And so you have client sides in orange, locals in blue, remotes in maroon. And the height represents the activity, and the density of the bubble, or the thickness of the bubble, represents the overall accumulative weight for the discussion. And there's reasons why they're all here, and there's reasons why like the remotes are higher, and I'll talk about that shortly. But all these bugs were quite interesting. There's more activity here in 2012. Again, the remotes are higher in terms of activity. MS12-020 I'll talk about. That was really, really funny because Twitter, like, basically, I was smashing them with requests, and it's just like sending back all this discussion. Some of it's not of much value, but it was a pain to process all this information. I'll explain why. And the client sides were all used in targeted attacks, and all had a lot of activity. So you have like some Java bugs, a couple of Flash, an IE, an Office, an XML parsing bug. And I'll explain why there's PHP, CGI ones, and MySQL bypass was popular as well. The key point for this is about analysis. Like, how can we get analysis information cross-referenced to vulnerabilities, which is two bits, exploitability, and then when stuff happens. So I had a little experiment when I worked on this talk. I looked at a bunch of different bugs that had exploitability information and ordered them by what was most popular. And I went through and I just listed them out here. There's about 15, I think. But it's a sample of stuff that has write-ups. And then the question, I didn't know the answer. I go, how many of these have analysis info and NVD, like a proper analysis information? And the answer is 1. So you have like dozens of like really big bugs that have really importance passing through this life cycle and getting to all these tools and to people. And it was all your common like vendor patch, which was referenced. Here's an example of a bug hunter who does a lot of Java stuff. And basically, as soon as the bug came out, he's like, here's my, basically he's saying, here's my format string bug, and here's my analysis. And I'll show why that's I'll show why that's interesting in a bit. There's other stuff here where, you have really good researchers who are doing extremely detailed write-ups about bugs they find or bugs they research, and it's worth a lot of money. Like, people pay good money for this stuff, and they're publicizing it for free, and it's all referenced and can be cross-referenced. This is by Thar. There's another one here by Vuln. They have a VRT team, or a VRT, and they do like consistently good write-ups as well. These are just a couple of examples. My general observations from all this data that's been collected is it's not rare for the guy who found it to write about it and publicize it somewhere. And there's a bit of a correlation about it being sold by brokers, so people who are buying vulnerabilities and then they're publishing the research. And it's usually them representing themselves or a team, a research team. So it's usually of a really high quality, and again, like related to the selling of it. It's usually after the vulnerability gets public. Guys, people from Vuln to Core, guys like Tajay and Juru, and also like Louis, who does Pentester Lab. He did some write-ups about some Rails vulnerabilities. In terms of the other side of things, not the exploitability, I could have gone through heaps, but I just chose several. There were 2 of them. These are all really, really big bugs. But there was 2 which had some information NVD from vendors and so on. But this is the sort of stuff you capture, like post-mortems from guys like Alien Vault Labs. Here's another write-up about a backdoor analysis. And again, like, it's companies representing themselves or individuals, and they do good write-ups. From the data I'll show, I see a pretty clear difference between stuff being in the wild, coming out and being exploited in the wild where the write-ups come out, and then there's a gap, and then like months later sometimes you see heaps of activity about all the infections. I'll show some examples. So this is a timeline trend. So this is thinking about the activity over a period of time and how it's all dynamic content, and that's coming in from social media. And some of it's really interesting. This is Java runtime vulnerability, which was quite big. You'll see why in a sec. First screenshot is NVD. I don't want to bash them. I use them for another project, which I'll talk about in a bit, so I think there's hope. But you see like unspecified, unknown vectors. You get references, which is like to the patch, basically. And it's like CVS 10, so it's bad, CVS 10. This is the timeline from talkback. And it's obviously, there's some peaks, there's some pretty big gaps. You can see a 1-month gap, a 3- and 4-month gap. And what happened was you have the bulletin come out, there's the analysis from some guy, there's a month gap, then it goes into Metasploit and black hole. Then you start to see targeted attacks against all sorts of people. 3 months pass, and then you get, there was a paper that came out, it became flashback malware, and you see activists being targeted and so on. And that goes up and down for a while. This is, I think, one of the best parts, is that you get people saying, there's an update which is out, I'm pretty sure this CV is mine. And then you get that second one is sort of like a bot that just pumps out advice, like, whatever. Then he goes, here's the details for my vulnerability, and then he has a blog post describing it in detail. So it's really annoying that like vulnerability intelligence feeds, or public ones, have like unknown vectors, and then like the same day it comes out, or the same week it comes out, you have this, which is a full write-up about it. This is the first peak when Metasploit and Black Hole came out on the timeline view, and you can just see that people are saying, how would you detect it, blah, 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 blah. Then all of a sudden you see that heavy maroon color say, here's the module in Metasploit, you should be afraid. And then a bunch of activity starts, and you can see that on the timeline bar at the bottom, that's quite consistent, steady information. Also the Black Hole exploit kit. Later on, there's a big gap, and then you see another timeline part, and you see about all the malware that starts to happen, and all people discussing what they're seeing. You can see many different languages here. I didn't translate it in this screenshot, but yeah. Another vulnerability is in Office. This I thought was a pretty interesting timeline, because this is a bit different than Oracle saying, here's our patch, and then people start discussing it and so on. This was something which was being exploited for IE. That's how it came about. So the timeline's a lot different. And there was a write-up by some guys at Execure, and there's a write-up by McAfee in Japan, like their labs there. So this information is starting to become really localized to a region and to countries, because that's where it's being detected in the first place. There's a lot of stuff about global campaigns and activists being targeted and so on. You get a Trojan called MS Update, and Alien Vault Labs did a write-up about it. And they did another write-up a couple of weeks later about more targeted attacks. And another gap, and then you see all these samples which are being released, and people sort of understanding how many are being targeted attacks and so on. Then at the end you see like this light activity. Oh, there's a little peak, but other than that, it's like some bumps. And this view shows that light activity. So I tried to translate it to English. A couple of them failed, I think, but some of them worked. But people are saying there's definitely more stuff coming, and some write-ups about some of the what they're seeing. But you also get end users who are being hit with malware as well, and they hop on Twitter and they say, "Hey, I just got this AV alert." It's pretty interesting when you map them back to where they're from. You can start to see some trends about clusters, like statistically, like where this is happening. That goes up a bit more, and you see like guys like Snowflow saying, here's some samples, and some people saying to guys like Mikko Hyppinen saying, I've seen a lot of targeted attacks, heads up sort of thing, you might want to tweet about it or whatever. And that top one I looked at and translated, and it was a write-up about ongoing targeted attacks. Didn't have any retweets, it was just from some guy. I thought that was kind of interesting. For this view, I switched to maps. Can't really see it. There was like a really heavy cluster in Tokyo with this view, but there was a lot of activity from this region, and most people were from Tokyo, so there's actually like a lot of laid markers there. But you can browse vulnerabilities this way as well. Patch Tuesday is a good one because basically every month without fail, there's like, things are going pretty steadily, then all of a sudden, bam, and there's all this activity that comes through, everyone's talking about the patches. But the common trend I've seen is you usually get guys trying to diff the binaries which are coming out, find exploitability index, and they're posting updates. This is one guy pointing out what function it's in for different platforms. And you get the stuff you would expect, like people diffing stuff, people trying to work it out, people asking questions. Some of it's useful, some of it's rubbish, which leads to hyper noise. I really like this part as well. The first one was the RDP vulnerability, which came out earlier in the year. So it's like a remote vulnerability in RDP protocol, and this was the highest peak of discussion. And to summarize the color codes for the bars, orange represents the total activity for that day. Unique represents after that post-processing logic, like trying to get rid of the junk that's repeated information, is that. And then the golden color is, for that day, what was the heaviest weighted item. So you can start to see what were the daily most important bits of information with this sort of trend. So you can see the huge peak, and then it sort of dies after a couple of weeks. If you try to attribute events or like layer on events to this timeline, you can see the bulletins coming out, people doing bin diffing. You can then see, if you're not familiar with this bug, basically, a proof of concept got leaked to on a Chinese in a Chinese forum, and it was equivalent to the one the researcher sent to the bug bounty program. And he's like, "Oh, there's a leak somewhere. What happened?" So he released his original advisory. So that's where all this activity is coming in this particular timeline. And there was also people on Pastebin saying, "I'm having fun backdooring people," so they're putting fake exploits on, and so you get that sort of stuff as well. A bit of time passed, and there was a script to detect it with Mmap, and that was, I think, one of the heaviest weighted items for this vulnerability. It was really popular amongst some demographics, and then it drops for a few days, and the Hacker News caught up, and they said, "Oh, hey, this information's out." And then there's another gap, and the company who found it were kicked out of the Microsoft program. And that's that final peak at the end of that timeline. This was a funny one as well, because this was a remote vulnerability in the TCP/IP stack for Windows, or UDP protocol. And it's a really abnormal bug to read about. Well, it's not that abnormal, but a lot of people were surprised by this. So the heaviest weighted item ever mined was a Chuck Norris joke about this bug. I think that summarizes everything, actually. But this timeline was pretty much the same as most Microsoft bugs that are critical and are remotes. You know, there's a blog post which is sort of cut off about looking at the exploitability for it, but obviously it died off. This final one is, the top 3 heaviest vulnerabilities were Microsoft. It was RDP, UDP, and .NET. And this .NET one was sort of was really interesting, actually, because Microsoft released this out of ban last year, and it was just before 100, so they were trying to avoid it. They would have wanted to avoid it, right? So they released 100, and obviously it's important, and they're saying, "Oh, it's about hash collisions," and so on. And the reason there's that last bump is the frequently asked question shop on Twitter said there's a new vulnerability out like 6 months later. So that stuff happens as well. And people are like, "Oh, this is bad." But the real problem was that in the new year, HD Moore, the company who actually found the vulnerabilities, released a full disclosure. This is the bug that was patched in MS 11.100, and it was an auth bypass. And then you have the link here to the information. So a lot of companies would have been like, "Oh, it's a hash collision attack," and if they don't keep up with this information, they miss this, which is really important, right? Demographics. There's actually some interesting stuff. I had to cut some stuff out due to time. In a nutshell, this is the way countries are distributed from people talking about bugs. Japan is very heavy. And you see there's some countries who you might say, "Why are they so small in activity?" And I've got some theories on that. And the next one is in terms of how people describe themselves. And you could over-engineer this to the max, but basically like just a generalization. This is how people describe themselves. It's a pretty interesting mix of people. You get journalists, you get activists, you get people with WikiLeaks, you get students, exploit developers, reverse engineers, and so on. It's a really broad mix of people. In a nutshell, I want to release some statistics about this. There's actually quite a lot of interesting stuff to talk about. But in general, a lot of the generalizations you would associate are quite true. Researchers that are most interested in PrivX, kernel bugs, really intricate remotes. Journalists, obviously whenever something's big or like hyped. And hacktivists were really keen on big remotes, your PHP bugs, your RDP bugs, the Mmap script for it, Java vulnerabilities, like, that sort of thing. That's some of the results for vulnerability references. The next part of it is, this was the point 2 about information security news. So sort of like, how can we leverage that work to do something completely different? So you have a pool of users, 20,000 plus users. What's trending? What's popular and trending amongst all these users of all different backgrounds across the world? And you can send off to Twitter, like saying, out of all these users, let's take regular snapshots about what they're currently talking about, how heavy it is, and so on. And it leaves me with this sort of like moment. I'm like, I've got all this data coming in. I'm stuck with the same problem, right? So the way I did it was basically collect all that information. We want to look at logic for processing it. We want to incorporate a basic manual moderation process to try to classify it. We want to revise that logic, review the statistics. We want to try to train the data set a bit, and then test, and then repeat. And the idea, cut down moderation time. I don't have that much time to do it, sort of defeats the purpose if I'm moderating it all the time. Remove regurgitation. So what I said earlier about the same people talking about different things. The same thing. Different people talking about the same thing. And try to trace back to the guy who posted it. I'm mostly interested in research. Like, that's what I want to see. So I want to find the researcher who posted it. I don't want some famous guy who eventually found out about it days or weeks later. So moderating stuff, this is after post-processing. Just try to classify it really quickly. And the result is a view like this. It's exactly the same concept as the other interfaces. We can browse the different categories. It's like a really quick and dirty classification. But you get around 30 to 40, you get a pretty steady amount of information that's coming through. There's like people talking about reverse engineering stuff, RDA plugins, Metasploit stages. It's really mixed. You get some comedy stuff coming in. The revisions to logic have, in a nutshell, been after a month, you're taking snapshots of tens of thousands of people, and you get people like retweets about celebrities saying something and all this other stuff. So it's kind of interesting. I'll go over it quickly. Basically, followers, retweets, all that stuff doesn't matter because it throws things out of proportion really fast. So you can have someone with 1 million followers, he or she could say anything and it gets 1,000 retweets, so it doesn't really matter. It's not a really accurate rate weighting. So you factor in retweets over the followers to get ratios, and tweets per day of the people who retweeted it, because if people are churning out retweets all the time, they're regurgitating information all day, right? That worked for a bit, and then no classification of items. So trying to do snapshots over time about how fast it's rapidly changing and so on. And I noticed some trends about things which were research related had very common attributes about keywords and so on. So I started to factor that stuff in. And now what I'm doing is very similar to that longest common sequence stuff, trying to get regurgitation down. That's quite a big problem. About 30 a day, items a day. An example of how this information is used and someone using the API this was quite cool. So basically there's a RSS feed about trending items. Some guy wrote some Ruby script, Ruby, to take that information and retweet it under a certain Twitter account. So there's this Twitter account which is retweeting all these trending items that are coming in. And I was like, oh, that's cool. And I thought about it. I really wanted to have like a newspaper view, like just really wanted to be able to wake up in the morning and go, like, I want to catch up as quickly as possible to get that out of the way. And I remembered that there's these people, they set up paper.ly, papers, and they subscribe to all these different Twitter accounts. And there's all this, it's usually filled with stuff every day, every week. So what I did, I was thinking, okay, well, my process is sort of cutting down that noise in a way, so then I pass it back to paper.ly. So that process does a big loop. It's sort of interesting, like the life cycle of each tweet to end up in this stupid newspaper. But it's actually really good, and I've been using this for a couple of months now. It's mostly research focused, but you get some comedy, you get some politics, you get some world news. It sort of just makes it in. But that's something to check out. It's on the website. I have some conclusions, like just to wrap up some of the points for this social media mining. Basically, there's obviously deficiencies with these Vuln feeds, but you can obviously improve on the data. There's heaps of information being captured out there. A common trend is that bug bounties and brokers who are buying bugs, really, since there's money now involved, researchers spend lots of time and skill to do this. They're more inclined to publish this work. That's a really important change in information coming out. Hype is really dangerous, even though it's natural. It really shifts people's perspective on risk. There was a talk at Breakpoint a couple of days ago from Matt Miller, who does Microsoft mitigation methods. He gave a really good talk on improving exploitability index. How can we rate vulnerabilities better? and because that really influences things quite a lot. Future of Twitter API, there's some questions about that. They might be closing it off in the new year, or like if they're not making money from applications like this. So I'll see what happens. Other mediums, so we saw dips from other certain countries where there's a lot of activity which is happening, but they're not in Twitter talking about it. So I started to mine for Weibo recently, which is China's Twitter, and long story short, there was some interesting data being captured, but my API key got killed pretty quick. And I didn't have the results, so it was all in a dev machine. So I want to incorporate it into TalkBack and maybe redo the API registration without being so transparent about what I was doing. One thing which is really important to bring up, like some of you might, there's probably a dozen people in here who are in the tool, at least. And one thing which people might get freaked out about is seeing their picture or whatever in some foreign tool that's not Twitter, and not a Twitter analytics tool, or not a Twitter, trending tool. This stuff happens. People are mining for this, and be very conscious about the way you type. If you're paranoid, be conscious about the way you type, your references, places, people, and so on, and also be conscious about your community. There's a lot of people doing analytics on this stuff. And as I said, like I'm going to do a write-up about some of the stuff I couldn't fit into this talk, but disinformation is really interesting. Patrick Gray gave a talk about how disinformation spreads, and a lot of this data captures that. A lot of stuff about analyzing the security community and how it fits together. Okay, so this is a preview about a tool called Tabasco. It's pretty easy run through. Like I'm not going to get into it too much. It's like a work in progress, but we'll see. My concept is that, introduce the topic. Auditing for bugs is very different. You can't grep for things like copy to use and mem copies as much nowadays. You'll still find bugs, but the stuff that's really important, not so much. And there's lack of tools for people who are auditing code manually. It's all about automation and so on, right? So my theory is that the more proficient you are, the more efficient you are, and the more patience you have, the better you'll be. That book on the right, The Art of Software Security Assessment, if you're into code auditing, just get that and read it. It's about 1,200 pages. It's very, very good. But yeah, we're after app-specific intricate bugs, right? Related work, there was a guy who talked about it last year about doing extrapolation of bugs. It was pretty interesting. Another one doing web commit mining this year. So my idea is pretty simple. I want to have a tool that aids a code auditor. So if I'm auditing a code block or whatever, or like a big pile of code with many technologies or many developers, which all of this has, I want to be able to learn it and understand it fast. And so any prior vulnerabilities I want to know about, where activity and changes are happening, density and code size and so on, and cross-referencing capabilities. So what I'm working on is a website to view a list of open source projects and see a lot of this information, probably summarize it more. I don't have time to do like web UI analytics and stuff, but web services to get this information, and then things like Multigo transforms and plugins for source insight. So what I've done, part of the prototype is mining Git, looking for exactly the same concept as TalkBack, mining Git for people talking about vulnerabilities, either in diffs, like inlining code, or in the commit messages, and then adding it to a big data model. Same with NVD. So NVD is actually not so bad. Like they have information about commit and so on. So I'm leveraging this data to map back to open source projects as well. Same process. Here's an example. So these are some Multigo transforms that I've just very, very recently started. Here's one. This is Linux kernel. This is a sample set of vulnerabilities. The green represents vulnerabilities and the orange represents files. Then I can start to navigate. And if you have seen Multigo, this can look all cool, but I didn't want to risk the demo. Next view is like viewing a vulnerability and understanding what files have been touched by this particular vulnerability. This allows you to learn about components which are affected pretty quickly. Another example is when you add more and more metadata. I want to know who signed off on bugs and who introduced bugs and what type of weaknesses they are and so on. Blue represents the guys who signed it off. So we have another transform about like, let's see who signed off these vulnerabilities. And then we can view in and start to say, right, this guy's responsible for patching this area. This is the code he's touching, and you can take it from there. So what I'm working on at the moment is integration with something called Olo. Olo is a really smart project, more about understanding the state of a program and the trends and developers and timelines and so on, and incorporate that into these transforms as well. Monitoring activity, so if you're interested in a specific block, whether you found a bug or whatever, then you can watch developers pass functions. Mining project management tools, so more entity types for like issues and bugs and so on, which are there. Expanding supported projects, so not just things like Linux kernel or other kernels, but like libraries for encryption or whatever, Apache modules. Source Insight plugin, so if any of you use Source Insight or any other like tool to read code, you want to see this stuff when you're actually reading through code. Multigo transform, I said, and machine learning, so basically some of the concepts that some of those guys talked about last year at Black Hat from Phen Elite, and it was really interesting. So I thought, like, once you build up this data set and build features for files, functions, code, developers, you can start to see some interesting patterns. So that's it for my talk. To wrap up, kind of interesting to see how you can use social media data. Like, you can use it in many interesting ways. Some guys were using it to predict earthquakes before it was announced recently. That was sort of cool, but Google was saying, like, earthquakes happening here. Talkback, I think I've spoken to some guys who maintain vulnerability inventories and said, look, I have this data which you can incorporate into your feeds, and they weren't that interested. So I'm going to send the slides to them, and they'll see why they might want to do that. And I'm going to write about some of the results, what I couldn't cover in this time slot. And for the Tabasco tool, like, if you're interested in this stuff, come and talk to me. Like, I'm developing it now. And yeah, come and have ideas or whatever. And yeah, any suggestions and feedback. So that's my talk. So.